Okay, good morning once again, grade 7. Our fourth discussion will be centered on the differences between a pure substance and a mixture. Thus, the lesson is entitled Mixtures in your module. But for now, we will use this. Uh, Sir, can I charge my laptop real quick? Yeah, yes, you can do it, Charles. So we will proceed with identifying what is a mixture and how is it different from the other solutions. No? Especially in your module, you have there different types of um, solutions. You have a pure homogeneous solution. You also have a heterogeneous solution. So later on, we will understand the differences between them. Okay, to start off, what is a coin? Now, what is this? What kind of a coin is this? This is a 50-cent coin in Canada. How big is this coin? Probably this is our questions that floats in the air, no? What's the color of this coin? What is the shape of this coin? What about the texture of this coin? And then the big question there is, what is this coin made of? In the old times, actually class, the coins are made of gold, silver, pure of them. But sad to say that people tend to destroy the coin to make it into a jewelry, destroy them to make it into an accessory or something like that. Is why our coins right now are alloyed with uh, two metals. Okay, it's just simply coated with a silver color, but it's not silver in its pure sense. Have you seen the movie um, the one wherein Abraham Lincoln is the vampire killer? How did they kill the vampires? They melted all the silverwares in the house of in the White House, or the silverwares of the White House, and then made it into bullets. So that's why they end up killing all the vampires. Okay, so much for that. Probably none of you guys are a fan of movies, no? So what will we learn for today class? We're going to identify the differences between a mixture that surrounds in your residence. We're going to determine the distinguishing characteristic between a heterogeneous and a homogeneous mixture. And also, we're going to distinguish between pure substance to a mixture. Okay? So before we're going to start the ball rolling, let's try to have this video for a while. Try this video. Share good. Can you see the video? Okay, so let's watch this video. Okay. So what was that video all about, class? Can you remember, or have you had prior knowledge on on how do you call that story then? The story about Archimedes and how he found out that the crown of King Hero was it pure gold or not. Actually, the end result there is he found it out through the so-called water displacement, if it is a pure gold or not pure gold. That is why in the last part of the video there, he told King Hero that the smith, the person who made the crown, was actually cheating King Hero, since the density of pure gold must be equal to the density of the crown, but it is not so. And how did he found out that the density of that pure gold? Getting the volume of that crown and then uh, divide it with a uh, mass, or rather getting the mass of the crown divided with the volume, thus getting the density. Perhaps you don't understand it for now, but probably when we have higher science lessons, we'll understand what is density. No? So let us continue then. What is the difference between pure and non-pure? So in this illustration, suppose you pick up a rock on a beach, you'll see some parts of it being gray, of it being white, of it being blue. So you concluded that it is of different colors. So probably that the rock is made of different types. Huh? So I hope that we can do this activity class, but never mind, we'll not do this activity. We're supposed to have this activity, but never mind. So let's consider this theory, particle theory of matter. All matter is made up of tiny particles, and these particles
Sir,
either, oh yes,
excuse me, sir. We can see the next slide, sir.
oh, see, sige. How about this one?
It's
Big
okay
na,
na, sir.
dako
But
na.
no, sir. It's still we can still see the next slide.
Ah, because sometimes I'll fix it for a while. Okay, I hope that this is okay na class. Where did we stop there? How about this one? Okay na? I hope it's okay. Thank you.
Yes, sir.
Okay, so we have here the particle theory of matter. Particle theory of matter is simply telling us that every matter in the universe, in the planet of the Earth, contains particles. And perhaps we can call these particles as atoms. They move in a way wherein they are made of. For example, the particles of a solid is closely intact with each other. The particles of liquid perhaps slides or collides with each other. That is why we can also determine the other property of a water as fluidity, no? Because the term there fluid means they slide past each other, but in a gas they just simply uh, bump to each other, and the distance between them is quite far compared to a liquid, and of course in a solid wherein it is tightly packed with each other. This is an example of fluid particles. The fluid particles simply slide past each other. It's like imagining a liquid or a water that you pour, the particles there simply slides with each other. Also, class, there are spaces among the particles, but in a solid, there is no such a space. Okay? The spaces class allows particles to attract other particles or mix up with some other particles. No? Substances, the particles of the different substances could either be mixed or could either not be mixed. If it will be mixed with the other particles, you can only see one component there or the particles that you mix class having two different colors, you can see two of the colors, or either you can see the two colors combined with each other, thus generating only one um, single appearance of that said um, substance. Okay, so substances could actually be either a mixture, or it could be either a pure substance class. Let me give you an example. Air, the air that we breathe, is it a pure substance or a mixture? The air that we breathe. Perhaps you later on you'll answer that question now. How about this one? Um, um, I think you're familiar with the next example. Fruit salad. Is it a pure substance or a mixture? It's quite obvious now the answer there. Perhaps, yes, indeed, that is a mixture. So, how about the air? The air that we breathe in. So, if you do have an answer already,
Pure?
then tell me later. Yes, someone answered that. Someone gave me an answer. Air is a Chelsea. What is that?
Pure.
Mixture. Yes,
Pure.
indeed. Pure. Oh, it's a mixture. The air that we breathe is a mixture of everything in the atmosphere. It could even contain dust particles. It could even contain the the famous virus that we have right now. So it's a mixture of everything in the atmosphere. That is why we have such protective measures to prevent us from having these harmful chemicals to go to our respiratory system. No? So pure substances versus a mixture. A mixture may have distinct visible components, and they appear throughout in the substance itself. So, for example, um, a mixture of oil and water. Now, if you notice, you place an oil on top of a water, or you place water on top of an oil, you still see the two substances that is being mixed up. We call that a mixture of oil and water, and this is called by the way, class, when you mix an oil and a water, and if they cannot be mixed, we call this mixture as immiscible substances. Immiscible, I think that's in your module class. Immiscible means they can't be mixed all throughout the process. No matter how you, what's the English of putaw? No matter how you stir them together, they won't be mixed. The term there is immiscible. Okay? How about this one? What about this one? The combination of a water and a sugar, no? The combination of a water, which is a pure substance, and sugar, which is again a pure substance, will end up with a mixture of a water and sugar. Okay? So, what do you think will be the idea of a mixture then? With these two examples, my example a while ago is water and oil, and then here we have water and sugar, and then a while ago fruit salad, and then a while ago air. When you talk about mixture class, you have to consider the components are combined, or two pure substances being combined. This is for the music. Okay, so the end result of a water combined with a sugar is what we call as a mixture. In other words, mixture is a combination of two substances. Okay. However, if you consider a substance, probably you can consider a substance as a compound. A compound or a combination of two or more elements, which is substances. Since water is made of the elements hydrogen and oxygen, as the molecule of water is called H2O. And sugar is a combination of three elements, carbon, hydrogen, and oxygen. As sugar has the molecular formula C12H22O11. No? So that is an example of a mixture. Again, a mixture is a combination of two or more pure substances. So other examples of a mixture, if you can have it there, you can feel free to unmute yourselves. So we have here another examples of other examples of a mixture class. So we have salt, water, a combination of water and salt, Kool-Aid, a combination of sugar and the other chemicals there that is present in the Kool-Aid, chocolate chip cookies, muddy water, salad, or a while ago I mentioned fruit salad, no? Salad dressing. The components of the air that we breathe is a mixture of carbon dioxide, argon, neon, krypton, xenon, helium, carbon tetrahydroxide, dihydrogen, oxygen, nitrogen, and all the elements that is present in the air, including the dust and other factors. No? By the way, what is the major component of the atmosphere that we breathe in, or the air that we breathe in? A, is it nitrogen? B, is it oxygen? Or C, it is carbon dioxide?
B.
B, which is
Oxygen.
oxygen. The answer is A. The main component of the air that we breathe in, 79% of which is made of nitrogen. Okay? It's nitrogenous. That is very good for root crops to to be able to make up um, the crops under the soil. No? Also, nitrogen is a good factor and an element which is supposed to be present in protein synthesis, the making up of the protein. Okay, what about pure substances class? So here are examples of mixtures, and also class, um, mixtures. Here we have mixtures may appear uniform. For example, sugar and a water may appear uniform as water itself, but it's a component already adding the sugar. So they also may appear not in uniform, like the chocolate chip cookie. You can have a cookie and a chocolate, so they may not be as one uh, component, which is chocolate itself or cookie itself. Also, this example, air is uniform. You cannot see all the other components, but basically every component of the air is present there. What about a pure substance? If components of the atmosphere, or if the components of a mixture may appear uniform, um, pure substance always appear as a uniform all throughout. Okay, in a mixture it may or may not appear uniform, but for a pure substance it could appear, it will always appear uniformly. Okay, so are you looking at your modules right now? All right, let me see your modules. So in your module class, you have here um, methods of separation or whatever. Some of the items that is mentioned in our presentation right now is not found in your module. For example, I did not mention there pure substance. I only mentioned um, uh, I only mentioned the mixture, but we have to consider the difference between them para later on in the understanding of mixture itself, we can determine whether that is not a mixture or that is a mixture in its sense. Okay? What do you mean wala gyapon? Okay? So let's continue. They contain either a single atom or two or more atoms chemically combined to form a different substance. Okay? A single atom, it could be um, the ozone, no? The ozone. What is ozone? Sorry, I off my camera. Internet is slow. Yeah, it could be. You can do it, Jamil. So, you know what's an ozone? It is located in our stratosphere. What is that ozone layer? Ozone has the ability to prevent the ultraviolet rays of the sun to go to the atmosphere of the Earth. That is our protective covering of the Earth. Without that ozone, we will be toasted we will be fried by the heat of the sun. Okay? Ozone is a pure substance that is only made with one atom, and that is an atom of oxygen, since the molecular formula of ozone is O3. Okay? Or it could be a combination of two or more atoms, like for example, water is a pure substance, and water itself is made of two elements, hydrogen and oxygen. Okay? Another example of a pure substance is this one, class. A limestone is a pure substance. It is a combination of uh, three elements, na? Liam and Lian get disconnected, sir. Um, no worries, this is recorded. So, yes, Liam and Lian, this is recorded. So, you need not to worry. Just review the session from time to time. Okay? Good, good. So, we have here the components of a limestone. Limestone is very much common uh, to be present in some hills or mountains, as this is also the main reason why we have mountains being eroded or being carved for it to be used to road pavements or whatever. No? So this is made of carbon, calcium, and oxygen. Thus, the molecular formula for limestone is CaCO3, or what we call as calcium carbonate. Okay. Notice, class, these molecules. Later, when we will use your periodic table, the video about the last lesson, there's no sound. Okay. Later on, I will attend to your concerns. So the later on, when we discuss further the periodic table, you will know how to read these molecules, class. You'll know how to read this as calcium carbonate without the presence of the word calcium carbonate in the paper or whatever. Okay, as mentioned a while ago, class, we have another example of a pure substance, and that is water. So water is a pure substance which is made of hydrogen and oxygen molecules. Okay, but this is not read in a technical term like the other one a while ago. The other one was calcium carbonate, but this will not be read as dihydrogen oxide. This is just simply read as water. Okay. The molecule of water is made of one oxygen and two hydrogen atoms that is connected through covalent bond. Also, you'll understand what is covalent bond when we discuss the periodic table, okay? Other examples of pure substances, class, we have here um, sugar. This I mentioned a while ago. The molecular formula of sugar is C12H22O11. Gold, which is in your periodic table, the element name is aurum. Copper or cuprum, carbon dioxide, the presence of the molecule, the atoms of one carbon and two atoms of oxygen. Oxygen gas is uh, is made of two atoms of oxygen applied using a covalent bond. So that is um, other examples of pure substances, class. So a quick review so far for the difference between a pure substance and a mixture. Pure substance is only one type, while mixture may appear two or more of the types. No? Water is a pure substance, but sweetened water or water with sugar is already a mixture. No? Gold is pure substance, but if you have a gold-plated necklace, it is already a mixture because the gold there is only plating or covering the alloy of bronze and nickel perhaps for that said necklace. No? We have here an example of a pure substance, distilled water, copper, uh, copper wire. This is calcium carbonate found from seashells. These are pure substances class. Another example of a pure substance, we have distilled water and pure gold. You know? Whereas we have here an example of a mixture class. When we are going to add a sugar to a water, we are now adding a molecule of sugar to the molecules of water. You remember when in our first illustration, molecules of water are separated by a certain distance. So when you're going to place sugar molecules in that said water, it will appear in between the water molecules, okay? Thus generating a mixture. Though it may appear, though it may appear in a single form, but if you taste it, then this is already the idea that the water is not anymore a pure substance. Rather, this is already a mixture. So what is particle theory again? The particle theory can help you determine whether it is a mixture as a substance by, of course, looking at the particles of the or the molecules of the said mixture. But since it is not possible for us to do as such because of the fact that we are doing this in an online session, so I'll just present to you pictures, no, of what particle theory is all about. Okay, these are simply models of how to determine a pure substance and a mixture. Salt as a pure substance, water as a pure substance. But if you're going to mix them together, you'll see the molecules of salt present in the molecules of water. Perhaps we can see this in an electron microscope, probably not much in a compound microscope. But if we look at it closer, some of the components of the salt will be um, dropped, or it will be present in the basin or in the bottom of the beaker. This is a beaker actually, class. Questions, clarifications, the differences between a mixture and substances. So we can proceed with the differences between a heterogeneous and homogeneous later. Question, clarification. Uy, walang question. So bigyan ko kayo na activity then. Never mind. Why not have this activity kasi wala kayong book. Okay, let's now proceed between the difference of a homogeneous and a heterogeneous mixture. This is the other group. How was it? Apa na? Lagi. Okay, again, sorry for the delay. There was just an important thing that we need to attend to for our research class. Okay, so let's proceed then. How about identifying the difference between a homogeneous and a heterogeneous mixture? Again, these are mixtures, okay? We're not talking here anymore about substances. These are now, no, we're not talking here about pure substances. We're talking now on mixtures, and this is the main deal of your module, okay? So what is the difference between both? If you look at the prefixes of the two words, class, homo and hetero, when you identify the definition, or when you look at the definition for homo, you'll only you'll see that the definition there is appearing one or only one. Hetero is more than one, di ba? Homo is one, hetero is more than one. No? So when we talk about homogeneous mixture, these can also be called solutions. No? Homogeneous mixtures or solutions can appear solid, they can appear liquid, or they can appear as gas. An example of a homogeneous mixture that appears solid is a stainless steel. Stainless steel or steel is an alloy of two or more elements, or two or more metals rather. No? You might not see it from your perspective, but as a um, metallurgist, no? The person who will is fond of combining two or more metals. So it could be determined by that said person. Also, when I mentioned a while ago of a gold-plated necklace, that is an example of a homogeneous mixture under the solid phase. For liquid, an example of which is the solution of water and and sugar. Okay. Sorry. For gas, you can have the expression of you can have the example the air is a mixture, homogeneous mixture of all the other elements in the air. Okay. So again, homogeneous mixtures are also called solutions. They can appear solid, liquid, or gas. The particles of a homogeneous mixture are evenly mixed. The particles of a homogeneous mixture are evenly mixed. This is pala the Kool-Aid, no? This is not the candy that what is in my mind, no? Kool-Aid is perhaps a combination of liquid to another component. No? I think this is a liquor, Kool-Aid. So the particles of a homogeneous mixture is or other are evenly distributed to the mixture itself. That none of the original substance is are visible. Example, a sugar to a water, then you can consider that homogeneous a mixture if you cannot see the sugar anymore in the water itself. You can taste the sugar because of the sweet tasting taste of the sweetened water, but you cannot then see the sugar components. Rather, you'll only see one component there, which is the water itself. No? They appear to be as one substance. And you can also consider that substance is a homogeneous mixture when light passes through, and light passes through unaffected. Because if there is already the affecting of the light as it passes through the solution, then that is not anymore a homogeneous mixture. Rather, you can call it as a heterogeneous mixture. Okay? Then regarding homogeneous mixture, you look at your module class. In your module as well, you have there the definition of a homogeneous mixture. Um, so we have here homogeneous mixtures are made up of two or more substances. They are also referred to as a solution, and in a solution, there consists a solvent and a solute. In a sweetened water, the solvent there is the water, the solute is the components that was dissolved in that said water, which is known as the sugar. Okay, and then we have several examples there of solution. So if a homogeneous mixture appears transparent, what do you think so will be the appearance of a heterogeneous mixture? Let's talk about heterogeneous mixture this time. Heterogeneous mixture is a mixture with different components being seen. Most of the time, heterogeneous mixture compared to a homogeneous mixture are opaque or translucent. No? They are also called mechanical mixtures because of the idea that there are other factors that can be seen. You can see more than one particles since the elements or the substances or the particles in the heterogeneous mixture is not evenly mixed or are not evenly mixed. Okay. So at this point, only Jeremiah is turning on the camera, or even Germana is turning off the camera. So, fine. Okay, so I will not entertain questions for those who are not going to turn on their cameras unless it's really a problem with the internet. Huh? So maybe I'll turn off my camera then as well. So, okay, let's proceed then. So we have here a heterogeneous mixture as well. The different parts of a heterogeneous mixture is visible. As I mentioned it a while ago, you can see one substance over the other by the time you look at a mixture. Also, you can look at that parts maybe by using a compound microscope. I hope that we can do an experiment on this one before in the in the previous traditional method of teaching, which is the face-to-face. We did had an experiment on this one, but then again, this is the new normal, so we cannot do as such. And also a while ago class, we have I did mention that the particles of the mixture is not evenly mixed. A concrete is an example of a mixture of a cement, sand, and gravel. No, this is a concrete. It's a mixture of a cement, sand, and gravel. Questions regarding the idea of a mixture? And what about a cloud glass? Is it a pure substance or a mixture? Probably this is already a mixture, right? But what is a cloud? Is it a homogeneous mixture or a heterogeneous mixture? What could be the idea of that said cloud? And if you look at a cloud, the light, if you look at a cloud, light cannot pass through the cloud. So therefore, clouds are heterogeneous since clouds are opaque. What is the components of a cloud? There are a lot of them. No, one of these are water vapor, the particles that is present there. Aside from that, is the components of the air. Okay, since light cannot pass through the clouds, so thus clouds is a heterogeneous mixture. So never mind with the student activity class. Actually, this can be done through online, but I think you are uh, it's not good to do this one for now. No? So we have here Tyndall effect class. A Tyndall effect is a phenomenon that can be used to distinguish whether the the, the substance appears as a solution or it will appear not as a solution. It will also distinguish between a solution and a pure liquid. Okay, what is a Tyndall effect? Um, Tyndall effect is uh, an idea of a light that passes through the liquid unaffected. We had the homogeneous mixture class. Um, Tyndall effect is not present in a homogeneous mixture, but it can be seen in a room wherein it is dusty and then it is as the sun rises. When the sun rises and then the light passes through the room, you'll see tidbits of dust that floats in the air. That is an example of a Tyndall effect. Okay, so there is a presence of another particles in the atmosphere, or whether it is in the water or in the air. There are a lot of particles that is present in the atmosphere. That is Tyndall effect. Light passes through the solution unaffected. No, that is what I mentioned a while ago. But in a heterogeneous mixture, there is a scattering of that said light. Okay, there is a scattering of that said light, and the scattering of that light is known as the Tyndall effect. Get it? Um, colloids are heterogeneous mixture expresses the condition of a Tyndall effect. The light will be scattered once it is going to pass through a heterogeneous mixture. But in a homogeneous mixture, light will pass unaffected. Lagbas na siya diha. Then, clarifications for homogeneous and heterogeneous. So here is what I mentioned about the colloids class. Colloids are heterogeneous mixture. They showcase Tyndall effect. Notice the area there. There's an illustration of a Tyndall effect there. The bottom picture. Where is it? Ayun. So this area here, class, is a Tyndall effect there. The molecules will distort the passing of the light. Uh, in your module class, we have here the methods of separation of a mixture. I did not prepare any presentation to this one because I think it can be explained properly, class. No? For example, by the way, the other factors that makes a heterogeneous mixture heterogeneous is the presence of some particles that you can see in the liquid itself. No, that that particles will basically that will be the source of why there is what we call as the Tyndall effect, since these particles will allow the scattering of the said light. No? An example of these particles can be seen in a suspension mixture. Are you familiar with a tambal that you need to um, shake first before using? Diba? There are some medicines that has the instruction shake first before using, uh, shake well before using. So we have here separation of mixture components, one of which is decantation. Decantation is defined as it's something that you need to do with the liquid, no? Decantation. If you pour the liquid out of the bottle, leaving the heavier particles inside, that is known as the decantation. But first, you need to have the particles to settle down in the bottom. Example, when you're going to mix a sand to a water and then you are going to stir it, the sand particles will be in that said water as it floats in the water itself. But allowing a couple of, uh, you allow a couple of minutes for the sand particles to settle down in the bottom, and after that, you are going to pour the liquid out of the container or out of the beaker, then that is the process known as decantation. Okay? But we also have another way to get the sand particles from the water glass. We also have the filtration. We can use a filter paper for the for the sand particles to be removed out of the water. This is mostly common to some extent on the old people in the living in the barrios. They they tend to create their coffee through by frying rice grains. Are you familiar with that? And I mostly do that one before when we don't have coffee left in our coffee bin. So we fry a rice and then it will become black. Put water on it and then mix up. Then the water becomes black. That is our coffee. So we eliminate the the filtrates by either scooping, no? And then some of them will settle in the bottom, so we do decantation. But most of the time, we use a filter paper, or if not a filter paper, a clean cloth to filter the grains from the rice. We call that filtered materials as filtrate. Okay. When we talk about mechanical separation class, it's just simply picking, no? Manual picking of the materials um, from the mixture itself. You buy a ding dong. A ding dong is a mixture of green peas, mani, cheese curls, and whatever. You can apply mechanical separation in a ding dong. Okay? You can just simply pick out the filtrates there. Seawater can be separated. The salt from a seawater can be separated by the mixture itself through evaporation. Uh, in the evaporation process, the water there will turn to will become a vapor and leaving in the decant decantation material or in a basin itself the remnants of the seawater, which is salt itself. Also, uh, in that said process, you can use the heat of the sun, evaporation, using the heat of the sun to let the water molecules to evaporate in the air. Distillation is the best way to separate components of a mixture which is composed of two liquids, no? Or rather, not decantation, distillation pala. No? The liquid with the lowest boiling point will be collected first by using vaporization or condensation. This is a more, distillation is a more sophisticated way of evaporation. In a distillation process class, you have a distilling tube. It's like a, in a laboratory experiment, you have this tube that collects the vapor, and then that vapor will again turn into water through the process of condensation. Okay, water from the sea can be can be turned into a drinkable water through the process of distillation. No? It can be done. It's just a, it just needs a proper and correct equipment. Paper chromatography, on the other hand, is using food dye, or it used to separate ink and food dye from the other components of the mixture or the water itself. No, paper. I'm not sure of how paper chromatography is being done because we have no access to the materials here in our school. Okay. What time did we started? 9:45. No. Really 9. Okay. Under paper chromatography class, you you try to mix some inks in a water and then it will float there at some point. But you try you put not even a paper. You can even use a towel or you can even use a cloth and dip it in the water. The inks will stick to the cloth, leaving the water clean with the ink. And that's still paper chromatography. It might not be the paper itself because I think I failed to access the exact paper used for paper chromatography when we had our experiment here at IA. Centrifugation is mostly famous in laboratories, especially when we differentiate the red blood cell, the white blood cell to the plasma itself. No, centrifugation is a centrifuge is a laboratory apparatus wherein the test tube will be placed in that machine and then it will create a centripetal force. The centrifugation um, moves the low density particles up and the high density particles in the bottom of the container. This is done in a laboratory class. You cannot do centrifugation on your own. Probably if you have a machine or if you can spin the 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 the, the molecules or the mixture itself, probably you can do that. But allows centrifugation can be done in a high speed centrifuge, a high speed spinning machine. An example of centrifugation can be also associated with dryer in your um, washing machine, no? Spin dry. That is also centrifugation, um, allowing the water molecules to be out of the soaked um, clothing. That's also a good example of centrifugation. So we have here different types of solutions. Solutions are actually homogeneous mixture, and solutions could either be um, hypo solution or what's the term there? Um, when you're going to add more solvent than solute, I forgot the term there. I think it's not present in your module. No? Here, supersaturated and unsaturated class. So when you talk about a saturated solution, that's equal number of solvent and solute. But if you have less solute and more solvent, that is unsaturated or ladang in sa Bisaya. If you are going to add more solute than the solvent, that is supersaturated or sobra katamis, no? Something like that. That is under solutions class, unsaturated or super saturated. You can use that to your to ask favor from your mom. No, let's say for example, mom, when Charles will ask his mom to timpla him with milk, perhaps. No, say for example, so you'll tell your mom, mom, can I have an unsaturated milk? So your mom will put less sugar to the milk or less milk to the water so that it will not be that sweet at all. Percent by mass and percent composition class, since we're going to have a review tomorrow, di ba? We'll have a review tomorrow. So this will be discussed further by tomorrow. However, I think we don't have much items in our activity 3. We only have 5 items in activity 3. So base from the examples on how you're going to answer activity 3. And the discussion of activity 3 will also be our review as well of the lesson about percent composition. Gets. Okay. So I am thankful for those who are always turning on their cameras, because as if I am talking to myself here when you turn off your cameras. Thank you for turning on your cameras most of the time, Shamil, Charles, Jeremiah, and Jillian a while ago. No? So as with Bench, most of the time, Bench turn on and turn off the camera. Para hindi naman ako naka-talk sa sarili ko. Turn on your camera. At least I am talking to someone in this session. Okay? So that would be all for today, class. Goodbye and thank you. Thank you for your presence today.